this brings up a few scenarios or even use cases I'm thinking of here, especially when it comes to gaming. So digital assets, right? So in games we have downloadable. So there are huge sites like Steam, which have games and other content that you can download, and just your any of your major kind of gaming platforms, Nintendo's, PlayStations. I'll tell you this: if you spend quite amount of time and you've invested time playing these games, and you start to develop digital assets, which you can actually trade, and so these things have value, right? And a digital asset could be skins, or it could be a component of the game, or even to unlock new levels, right? Or even just custom content, or even very hard to acquire content, right? Might be a secret level of a particular game. How can you deploy your platform in order to protect against either somebody hacking into it and actually stealing that, for to actually trade it, or to just keeping that secure within an esports organization, outside of just anything like malware, or ransomware type of events?
Yeah, absolutely. I think, let me give you an analogy. You can use secure enclave technology to create output, which are a set of assets.
Mhm.
Let's say the program awards you some set of assets, which are encrypted to your key, so only you have access to those assets, and those assets can't be seen by anybody else. Unless you share the key with somebody else. Okay. Number two, we can also make it possible that even you can't change those assets. You can view the assets, but you cannot make changes to the assets. So you can't add or subtract your own scores or add to the number of assets you have.
All right.
So the main thing is that the outputs of the games have a state which is defined by computations within the secure enclave. Mm-hmm. And the game assets and the scores, etc., have no sort of existence or state outside the secure enclave. They are simply manifestations of computations that are always occurring from within the protection offered by the secure enclave.
Oh, so again, going back to our topic of the hardware, so that validation is actually done with the hardware based on any enclave that you've set up, right? So
it's done by keys which are protected by the hardware. Yes.
Gotcha. All right. So if we have, let's say we're a developer of a game, right? We've spent millions of dollars, and somebody decides that they're gonna leak this game out there. How can we use this platform to solve that issue? To solve for that issue?
I'm sorry, could you repeat the question?
So let's say we have this game. We've been working hard on it, but we don't. Somebody leaked it out. That's loss of development time. You have to go back.
You want to protect the code base of the game itself.
Let's protect the actual game code itself. Yes.
Yes. So as I said, we in Safety Share always think in terms of at least two different types of assets: the code base and the database. So the code base is protected by a particular feature of confidential computing called measurements. There is a particular piece of technology called cryptographic digests. You can take a piece of code and you can create a digital digest of that, which is an internal hexadecimal representation of the code base. And you can have that as your baseline version of the code base of the game. You can then program the secure enclave to ensure that any time the code base that runs inside the secure enclave is exactly bit for bit the same as the code base which you are using as a baseline. So if somebody has come in and altered the code base, that code base will no longer run inside the secure enclave.
So for software development, so the game developers themselves, they create the code and they're pushing updates. How is that affected the process?
Each time you have a rev that you have finalized, the developers will then create a new baseline version, and from then on, that baseline version will always be the one that will run inside the secure run.
Unless it's updated, right?
Unless it's updated and re-signed by the developers.
Yeah. So
and a new baseline is created. Yes.
So I'm military, and you know, when we briefly spoke last week, you'd mentioned you'd used the word skiff, right? And this is really intriguing because this gives us a level of security that even inside of the secure environments, you could have deeper levels in order for access to any type of PII or different content. So kind of walk us through that, especially with, you know, again, we're talking about, you know, using this in an esports or gaming, you know, application here. You know, if you had, take for example, the Army did a brilliant commercial trying to find hackers, right? Yeah. So they had the standard, you know, Army, you know, join the Army, whatever it is, and at the end of it, there was a TV screen, or actually it was a computer monitor, and there was just some code that was stringing across of it. But you know, if you weren't a hacker, you wouldn't know that, right? But that led to an actual challenge, right? And so they kind of you know, filtered out a lot of the level of experience, you know, because if you don't know, you don't know, right? Right. And I found that really, really cool. So in this case here, you know, being able to get to different levels of access inside of the Enclave, that's pretty intriguing. So tell us a little bit about that, man.
Yeah, so the basic analogy I made, because you are ex-military, I made the analogy to say that you can think of a secure Enclave as a skiff. It's a software abstraction of the skiff. It's not a physical thing, right? I mean, it's a physical thing in the sense that it's created inside the memory of a computer, but software does the job. But like a skiff, you only enter if you are authorized to enter. Number two, you can only do certain actions based on the policies that govern what you can do inside the skiff.
Oh.
Okay, so there is a policy server running inside the skiff that is saying you can do this, but you can't do that. So you have access of this type and you don't have access of that type.
So you could still get access to the information and still may not be able to edit or modify the information based on the policies that are set up. And guys, for the non-military folks who are watching this, the skiff is just a secure room or secure location that, you know, requires a high level of security, most likely a top secret clearance for you to get inside in order to you know, to view the information. So yeah, this is really cool, man. So you can get inside the actual
you can get inside if you are authorized.
If you're authorized, right? And then once you get in there, it may be limited to whatever the policy is restricted to, which could be view or edit or you know, modify some type of information, right?
Yeah. So you are inside the skiff, which stands for Secure Compartmented Information Facility.
Correct.
If you are inside the skiff, and there are a set of internal policies that restrict the set of actions that you can do. So there may be data that you can look at, and there may be data that you can't look at, or you can read, but you cannot edit, etc. So all of that is under strict policy control. There is a set of policies being specified outside the skiff that are executed, enforced within the skiff by the policies mechanism, by computer programs inside the secure facility. Now, what is interesting is that even the outputs that you can generate from within the skiff are controllable by these policies. So you can say this output can go to party X, but not to party Y. And the way you make that happen is that you encrypt the output with certain keys that are only available to party X, but not to party Y.
Ah, gotcha.
So therefore, I can have multiple outputs going out from the skiff or the secure enclave. I can have one going to you, another to your partner, but these two may not be shareable between you and your partner at all because the keys are different.
Well, this is
By
really
keys, I
intriguing.
mean the set of encryption keys.
Yeah, yeah. Even from again the military standpoint, or even think of a large organization, being able to expose data and to really limit the way that that information can be used, right? And who has access to it, right? Inside the skiff again, right? That is pretty cool.
Yeah.
You know, I think the last question that I have is if we well, let me say this. With the emergence of esports and even in educational settings, and also the workforce, utilizing gaming as we move forward, it's going to be a bigger part of our lives, right?
Yeah.
And we could extrapolate this across so many even just hell, Texas has the lottery online. You can get your lottery tickets online, right?
Yeah.
So there's numerous forms of gaming, and and again, this will bring in bad actors, but I think that the data at the end of the day, being able to secure the data, and also what you're saying is to secure the computation and the code processing inside of the those secure enclaves, that is pretty critical. One of the things that I see that is probably going to happen would be the ransomware of professional esports players, or even in a training setting. How could we use technology like this to even prevent that, at the essentially from the web perspective, right?
Yeah. Let me say a few things. One, I have mentioned secure enclave, but I want to stress that a secure enclave is not a single entity. There could be a whole series of secure enclaves that are interconnected. This is
Okay.
so it's not a single skiff, it's a whole series of skiffs.
Yeah.
That data and control can flow, keys can flow from one skiff to a second skiff, etc. And the reason that is important is that as games need scalability, as the number of players grows, or the state of execution grows, you may run out of room. Let's say, for instance, you may run out of memory in a secure enclave, and you may need to spawn new secure enclaves. So from the scalability of the platform point of view, it's sort of important to understand that these secure enclaves are a series of enclaves that can be created as and when they are needed, and they are all interconnected. And when a new enclave comes online, it attests itself to the other enclave before the data can be shared with it. So there's this growth scalability phenomenon. I think that a very strong argument can be made that by using confidential computing and trusted computing, and by using confidential computing and trusted execution environment technologies, games can, and the players and people who watch the games will get a sense that the game is being played fairly, that they can trust what they are seeing and what is being told to them, and the player's integrity and the game's integrity is being vouchsafed. I think that is going to be the biggest winner of the use of confidential computing in these circumstances. Now, as it becomes more and more a part of our lives, and we all play games, and we find many other uses. So, for example, there is widespread concern in the gaming community that machine learning and other smart AI tools, etc., could be used in nice ways to sort of enhance the value of games, but they could also be used in dangerous ways to corrupt the gaming experience. But again, having security concerns front and center, and I don't mean to claim that confidential computing will solve all these problems, but certainly there is a nice set of problems that seem to be solvable by the use of confidential computing in the use and playing of games.
This brings up an interesting question. Even the communications portion could be within the enclave itself?
All the communications could be mediated by entities within these secure enclaves. So, for example, if you're communicating with a database or you're communicating between parties, the
Right.
secure enclave could be the trusted agent in the middle.
And so even we're on Zoom right now, if you could essentially kind of verify the efficacy of the actual communication streams.
Absolutely. You can. In fact, let me bring up an interesting possibility. As this recording is being made, how do you know that the recording is a true reflection of what you and I are saying?
Beat me to it, my friend. Yes.
There is no robot that is listening to this conversation and replacing every second sentence by some spurious new sentence.
Yeah. I mean, there's greater implications even with now ChatGPT and the text to image and text to video. We have bad actors using this right now to create kind of deep fake videos. So yeah, I mean, this goes way beyond gaming, and I'm sure we'll have much more conversations about different use cases. But yeah, it's very serious.
So we take a recording of this game, and we suddenly find that Nigel is heard to be saying that games are this or that, which he never said.
Yeah. Or so even again back to esports, code of conduct, right?
Yeah.
We talked about swatting, right? Now, hey, I don't like you, so now I'm gonna say, create this fake video with you saying pretty derogatory or defamatory things against a particular person or against a particular sector, right? And now you as a professional esports player, or just an athlete in school, now you're banned and you've been hit with disciplinary actions. So yeah, it's really important, what we're discussing.
Yeah, you can go to fairly sort of esoteric use cases using generative forms of AI or sort of adversarial forms of AI. But there are even simple attacks. So for example, if you have a code base and you change the random number function, a lot of games use random number functions all over the place. If I change the random number function, I can create very spurious results. So how do you know that has not happened?
Yeah.
Right. So simple attacks could have far-reaching consequences, and esoteric attacks could change and create a new set of problems that we can only sort of barely discuss and talk about and sort of imagine.
Yeah.
I mean, I can see the game showing that somebody said something defamatory about another player, but then the person could sort of deny the whole thing and say, no, I never said that. There is a robotic program in the middle of the conversation that was interposing itself into the conversation. Well, if you have an immutable log generated by the specific hardware that is being used by the platform, it's pretty undeniable that this immutable log is a true audit of the entire computation.
So we've been talking a lot about the use cases as the players, or even maybe a programmer in terms of the actual gaming content, right?
Yeah.
And I think this, this is fitting to kind of bring our conversation to a close here. You talked about this immutable logs, right? From a cyber practitioner or cybersecurity perspective, how does your platform make their lives easier? If somebody comes in to do an audit, or there is some type of situation, right? Incident response, how can your software and your platform help them, get down to the crux of what the issue is?
So the one fundamental problem that confidential computing solves is this idea of a trusted party. At the moment, in most computations, the platform provider acts as a trusted party. So when you run your game on a platform, you are relying on the platform to execute the game in some honest, fair manner, and you are being given a guarantee by the service provider, by the platform provider, that their platform is not doing anything. Confidential computing says you don't have any trusted party in the middle. The hardware itself attests to the sanctity of the computation. There is no trusted middleman. There is no broker. The platform provider is not in this security equation at all. The platform itself attests and says, I executed this workload, and I attest to the authenticity of the actions taken by this computation. And here is the log of all those actions. So you are now, in some sense, you, the owner of that game, can turn over the records of that audit log to a regulatory body or whoever needs to know. And they don't have to come and take your oath or put you under oath or charge you with perjury, etc., because the hardware itself is taking care of all of that. So there is no trusted party in the middle that is needed if the confidential computing technology is being used.
So this sounds like this would be a good solution for anybody looking for a zero trust type of configuration or solution within their environment.
Yes, with the proviso that there is only one thing you trust in such a situation, which is that you trust the hardware.
Really enjoyed the conversation. So I'm looking forward to continuing this conversation. Thank you for being here with us, and we'll sign off here.
Thank you, Nigel, and thank you for asking wonderful questions.